Hi, scientists. Today we're going to look at how to write a science lab report, and the focus is on the conclusion. Comes from a series of videos that I've done on how to write a science lab report. So if you haven't seen the previous ones, I highly suggest that you look at them first. We have 3 previous videos. The first one is on background information, hypothesis, and variables. Next is the method, and then the third one is the results. So you can use the QR codes to access those. So for this one, we're going to look at the conclusion, and I'm going to show you how to write the conclusion of your science lab report. What we will do is we're going to use the data to answer the original question that we had. We're going to describe the relationship between the variables, and then we're going to identify patterns or trends in the results. We're going to use scientific reasoning then to explain what happened. So your goal is to write a conclusion that can stand alone and clearly show what your experiment revealed. This is what real scientists do. So let's look at the conclusion. The purpose of the conclusion, again, is to answer the original question using the data. It should stand alone. In other words, someone should be able to read and understand what you did. This is what you should discuss: what you observed, any patterns or trends, explain any outliers, and for your wording, you can use first or second person. So you could use the words like I, we, you, our, and my. But do not use words like prove. Instead, use the data supports that. Remember, in science, we never prove, we only disprove. And remember also to cite any research in your text and in your bibliography. You're going to describe the relationship now between the independent and dependent variables. So you would say, as the, whatever your independent variable is, whether it increases or changes, what happens to the dependent variable? How does it change? Does it increase, decrease, or is there no pattern? Then you're going to have evidence to support the stated relationship. You say the data that supports this is, and you would say it in your table and also in your graph. Then you want to find out whether or not your hypothesis was supported. So you'd say the pattern in the data either supports or does not support my hypothesis, and then explain why. Then you're going to explain your results, and you're going to use scientific reasoning. So you would say the science knowledge that could explain my results is, and then you would state what that scientific reasoning is. Remember always to document your source. So let's look at an example. And again, we're going to continue with our helicopter experiment. So we're going to first describe the relationship between my independent and dependent variables. So my independent variable was the wingspan. That's why it is in yellow. And the dependent, again, is the time it took to fall, which is in turquoise. So as the wingspan decreased, the time to fall also decreased. Evidence to support this stated relationship? Well, in my table, the data that supports this is when the wingspan was 5 centimeters, the time it took to fall was 3 and 3700 seconds. When the wingspan was 4 centimeters, the time it took to fall was 2 and 57 hundredths of a second. And when the wingspan was 3 centimeters, the time it took to fall was 2 and 43 hundredths seconds. Notice again, my independent variables are in yellow and my dependent variables are in turquoise. And I used the data from my processed table. I don't use the data from the raw table. The processed one, again, it's the mean that I'm using. In my graph, as the wingspan decreased, the time it took the helicopter to fall also decreased. That was a positive correlation. So that's how I saw it in my graph. Is the hypothesis supported? The pattern in my data supports my hypothesis because when the wingspan decreased, the time to fall also decreased. The data shows that when I removed 2 centimeters from the wing, it took 9,700 seconds less to reach the ground. Now I'm going to explain my results using scientific reasoning. The scientific reasoning that could explain my results is that, quote, air resistance is the result of an object plowing through a layer of air and colliding with air molecules. The more air molecules which an object collides with, the greater the air resistance force. Subsequently, the amount of air resistance is dependent upon the speed of the falling object and the surface area of the falling object. Based on surface area alone, it is safe to assume that for the same speed, the elephant would encounter more air resistance than the feather. And this came from an article that was on the internet, and the name of it was Elephant and Feather, and the ND means there was no date given. So, what makes a strong science conclusion? Well, it clearly answers the testable question. It describes the relationship between the independent and dependent variables. It uses specific data as evidence, and it explains whether the hypothesis is supported. It uses science to explain why the results happened. And again, it avoids the word prove. Instead, it says the data supports. A great conclusion doesn't just say what happened, it helps us understand why it happened. If this video helped you and you liked it, please click the like button. Feel free to leave a comment. And if you haven't yet, please subscribe. That way you have access to all of these videos. As always, thanks so much for watching.